Right now, you are living inside a structure so enormous that if you could somehow travel at the speed of light, the fastest anything can move in this universe, it would take you 100,000 years just to cross from one side to the other. That structure is not some distant cosmic mystery. It is your home, the Milky Way galaxy. You have seen its name 1,000 times. You have seen the diagrams. You think you know what it looks like. But tonight, we are going to dismantle every comfortable image you have ever held about this place. Because the true size of the Milky Way is not just large. It is so vast that the moment you actually understand what it means, the word home will never feel the same again. If you enjoy having your entire sense of reality quietly dismantled, do me a favor and hit that like button and subscribe. It genuinely helps this channel keep making these deep journeys into the cosmos, and I appreciate every single one of you who sticks around for them. Now, settle in and get comfortable. Let's begin. You have seen it 1,000 times, the image. You know the one. A beautiful spiral galaxy photographed from above, perfectly symmetrical, glowing arms curving outward like the blades of a slow-motion fan. Somewhere near the outer edge, a tiny arrow points to a dot, and beside that dot, 2 words appear in clean white text. You are here. That image is in every textbook. It is on every science poster hanging in every classroom, from middle school through university. It appears in every documentary, every pop science article, every animated explainer video about the cosmos. And the moment you see it, something clicks in your brain. You think you understand the Milky Way. You feel it settle into your mind the way a map of your city settles in after you have looked at it enough times. There is the center, there are the arms, there is our sun, sitting politely in its designated neighborhood. Everything makes sense. Everything fits. And that is the lie. Not a deliberate lie. Nobody set out to deceive you. The image is not technically wrong. The proportions are roughly correct. The spiral structure is real. The location of our sun is placed more or less where it should be. But the image does something far more dangerous than being inaccurate. It makes the Milky Way feel manageable. It takes a structure so vast that light itself needs 100,000 years to cross it, and it compresses that structure into something that fits on a single sheet of paper. Your brain looks at it and unconsciously applies the same spatial logic it uses for everything else in life. A road map, a building floor plan, a chart of the London Underground. You absorb the layout, note the landmarks, and file the whole thing under understood. But you have not understood anything. You have merely been given a shape. The actual distance that shape represents, the real physical separation between one side of that spiral and the other, never enters your body. It stays abstract. It stays safe. And because it stays safe, you walk away from that poster, that textbook, that documentary clip, believing that the Milky Way is a large but ultimately graspable thing, a cosmic neighborhood, a galactic home, a place you could theoretically orient yourself inside the way you orient yourself inside your own country, with a center over there and edges over there, and your position marked neatly somewhere in between. It is not that simple. It is not even close. The Milky Way is a barred spiral galaxy. That designation tells you something important right away if you listen closely to the language. It is not a star. It is not a solar system. It is not a cluster of stars bound together in a tight ball. It is a galaxy, an entire gravitationally bound collection of stars, gas, dust, and dark matter. All of it spinning through space as a single coherent structure, so large that it contains within it nearly everything you have ever seen in the night sky, and vastly more that you have never seen and never will. The European Space Agency's Gaia spacecraft, which spent over a decade cataloguing the precise positions and motions of nearly 2 billion stars before its science observations concluded in January 2025, confirmed and refined what astronomers had suspected for decades about its architecture. The Milky Way has a thick central bar of stars running through its core, with multiple spiral arms trailing outward from the ends of that bar like water spinning off the blades of a lawn sprinkler. The whole thing is shaped roughly like a disc, thin relative to its width, with a bulge at the center where stars pack together more densely, and a sparse extended halo of ancient stars and globular clusters surrounding the disk above and below. If you could somehow fly far above the galactic plane and look down upon the full structure, you would see something that looks eerily similar to photographs of other spiral galaxies scattered across the universe. Elegant, ordered, strikingly beautiful, even. But here is what that top-down view would conceal from you. The disk you are looking at, the main stellar disk where the vast majority of the Milky Way stars reside, stretches approximately 100,000 light-years from one edge to the other. That figure comes from multiple lines of evidence accumulated over more than a century of observation, beginning with Harlow Shapley's pioneering measurements in 1917, when he used the positions of globular clusters to estimate the galaxy's extent, and it has held up remarkably well across subsequent decades of increasingly precise instrumentation. Some recent studies tracking chemically young disk stars at the farthest detectable reaches of the galactic outskirts suggest the stellar population may extend somewhat further than the traditional boundary. But the most widely cited and broadly accepted figure for the main stellar disk remains approximately 80,000 to 100,000 light-years in diameter, with the disk being only about 1,000 light-years thick outside the central bulge. That is the number you will find in sources from NASA to the European Space Agency to peer-reviewed astrophysical journals. 100,000 light-years. It sits on the page so calmly, it is printed so casually, stated so flatly, that your brain processes it the same way it processes any other large number it encounters in daily life. The population of a country, a government budget figure, a statistic in a news headline. You hear it, you nod, you register that it is big, and you move on. You never once stop to feel what it actually means, because your brain has no mechanism for feeling it. You have no evolutionary hardware designed to process a distance of that magnitude. You can say the words. You cannot hold the reality. And yet, despite this fundamental incomprehension, the Milky Way is treated as the starting point, the familiar place, the thing we already know before we begin talking about bigger, stranger, more exotic structures out in the universe. Documentaries about the cosmos routinely blow past our galaxy in the first 30 seconds of runtime, eager to get to galaxy clusters, cosmic voids, the observable universe, the multiverse. The Milky Way is the opening act, the warm-up, the throat clearing before the real performance begins. It is the thing you are supposed to already understand, so the rest of the story can land with proper impact. But nobody stops to ask whether you actually understand it. Nobody checks whether the image on the poster did its job or merely created the comfortable illusion that the job was done. The assumption is that because you have heard the name Milky Way since childhood, because you have seen the spiral diagram so many times that it feels less like something you learned and more like something you have always known, you have internalized what it represents. That assumption is catastrophically wrong. Familiarity is not comprehension. Hearing a name 10,000 times does not mean you understand the thing the name refers to. You are familiar with the Milky Way the way you might be familiar with the word infinity. You have heard it. You can use it in a sentence. You could not hold it in your hands if your life depended on it. Let me tell you what the Milky Way actually contains, because even the basic inventory is enough to start cracking the comfortable picture apart. Current estimates place the number of stars in the Milky Way somewhere between 100 billion and 400 billion. The uncertainty in that range is itself staggering. We are not sure whether our galaxy contains 100 billion stars or 4 times that number. Think about what that uncertainty means. It means the margin of error in our star count is roughly 300 billion stars. That is not a rounding error. That is not a minor adjustment to be refined with better data. That is 300 billion entire suns, each one a nuclear furnace potentially orbited by its own retinue of planets, and we do not know whether they exist or not. The reason for this enormous margin is simple and humbling. We cannot see most of our own galaxy. Thick lanes of interstellar dust and gas block visible light in many directions, especially toward the galactic center and through the dense plane of the disk. Infrared telescopes and radio observations can penetrate some of this obstruction, peering through the fog to detect the thermal glow of hidden stars and the characteristic emissions of hydrogen gas. But even with every telescope and survey humanity has ever built, even with the most comprehensive stellar catalogue in history, assembled by the Gaia mission over its decade of painstaking observation, we have directly measured only a fraction of the Milky Way's total stellar population. Gaia catalogued almost 2 billion stars, which sounds extraordinary until you realize that 2 billion may represent as little as 0.5% of the galaxy's total. The galaxy we live inside is partly opaque to us. We are trying to count the trees of an immense forest while standing deep within it, hemmed in on every side by trunks and branches, and a fog that thickens and darkens the farther we strain to look. Among those hundreds of billions of stars, the variety is immense. Red dwarfs, the smallest and dimmest hydrogen-burning stars, make up roughly 70% of the total population. They are so faint that most of them are invisible to the naked eye, even at distances of just a few light years, yet they outnumber every other type of star combined by an enormous margin. Blue supergiants, thousands of times more luminous than the Sun, blaze across the spiral arms in brilliant but short-lived displays of nuclear fury, burning through their fuel so fast they live and die in just a few million years. White dwarfs, the dense remnants of stars that have exhausted their hydrogen and shed their outer layers, litter the disk by the billions, slowly cooling over timescales longer than the current age of the universe itself. Neutron stars, the crushed cores of massive stars that died in violent supernovae, spin at extraordinary speeds in the wreckage of their own explosions, some rotating hundreds of times per second while beaming radio waves into space like cosmic lighthouses. And scattered throughout the galaxy, in numbers we are still working to pin down, stellar mass black holes sit in silence, warping space-time around masses they consumed long ago, detectable only when they happen to interact with nearby matter, or when gravitational wave detectors catch the ripple of two of them spiraling together and merging somewhere in the dark. At the very center of it all, roughly 26,000 light-years from where you are sitting right now, lies Sagittarius A star. This is the supermassive black hole anchoring the entire galactic structure. Its mass is approximately 4 million times that of the Sun, compressed into a region smaller than the orbit of Mercury around our own star. In 2022, the Event Horizon Telescope collaboration released the first direct image of Sagittarius A star's shadow, confirming decades of indirect evidence with a visual observation that stunned even the scientists who produced it. Everything else in the galaxy, every star, every gas cloud, every rogue planet drifting through interstellar space, every speck of dust in every nebula, orbits around the collective gravitational center of mass that this black hole dominates. The galaxy is not a static arrangement of lights pinned to a dark canvas. It is a vast rotating system, held together by gravity, organized around a core that contains one of the most extreme objects in all of nature, an object so dense that not even light can escape its surface once it crosses the event horizon. Now let us talk about where we actually sit inside this structure, because our position matters more than most people realize. The Sun resides in a region called the Orion Arm. For a long time, this feature was classified as a minor spur, a small and relatively insignificant bridge of stars and gas connecting two of the galaxy's larger spiral arms, the Perseus Arm on the outside and the Carina-Sagittarius Arm closer to the galactic center. Older maps of the Milky Way often labelled it the Orion Spur, or local spur, treating it as a secondary feature rather than a true arm, but successive data releases from the Gaia mission changed that picture substantially. Analysis of the spatial distribution of young, hot, massive OB-type stars confirmed that the Orion Arm is longer, more substantial, and more clearly defined than those older maps had suggested. It stretches roughly 10,000 light-years in length and about 3,500 light-years in width. It is still not considered a major arm on the scale of the Perseus arm or the Scutum Centaurus arm, but neither is it the trivial side branch that earlier cartographers had assumed. It is a real structural feature of the galaxy, rich in star-forming regions and molecular clouds, and our entire solar system is embedded squarely inside it. The Sun's position within the Orion Arm places it approximately 26,000 to 27,000 light-years from the galactic center. That distance means we sit roughly in the middle zone of the disk, not near the center and not at the far edge, but somewhere in the broad intermediate region between the two. From our position, we look inward toward the dense glow of the central bulge, visible to the naked eye as the brightest and widest part of the Milky Way's band, stretching across the summer sky in the direction of the constellation Sagittarius. And we look outward through the thinner, sparser outer regions of the disk, where stars become gradually less frequent and the spiral structure slowly dissolves into the darkness of intergalactic space. Our position is not special, it is not privileged, it is not the center of anything significant. It is simply where we happen to be, one star among hundreds of billions, orbiting at one particular distance from a central mass that most of the galaxy shares. And that sheer ordinariness is part of the problem with the poster. The arrow pointing to "you are here" makes your location feel notable, marked, important. In reality, you could place that arrow on any of hundreds of billions of other stars scattered across the disk and the diagram would look functionally identical. We are not landmarks in this structure. We are not even easily locatable. We are one anonymous point among hundreds of billions, and the arrow on the poster is the only reason anyone can pick us out at all. Now, here is where the first serious crack appears in the comfortable image. The crack that, once you notice it, begins to spread through the entire structure of what you thought you knew. The Sun is not standing still inside the Milky Way. It is orbiting the center of the galaxy at a speed of approximately 230 kilometers per second. Convert that into more intuitive units, and you get roughly 514,000 miles per hour. That is fast. It is fast by any human standard imaginable. It is faster than any spacecraft we have ever built. Faster than any bullet fired from any weapon. Faster than the orbital velocity of the International Space Station. At that speed, you could circle the entire circumference of the Earth in under 3 minutes. You could travel from the Earth to the Moon in less than half an hour. You could cross the distance from Earth to the Sun in roughly a week. And yet, even travelling at 514,000 miles per hour, continuously, without slowing down, without stopping, without deviating from its path for even an instant, the Sun needs approximately 225 million years to complete a single orbit around the galaxy. Let that number settle into your mind. 225 million years, that is one galactic year, one full lap around the Milky Way, not a trip across the galaxy, not a journey from one edge to the other, just one circuit around the center at the Sun's particular orbital distance. The Sun was born roughly 4.5 billion years ago, which means, in its entire existence, across every geological era, every extinction event, every epoch of planetary transformation that has shaped the Earth and everything living on it, the Sun has completed approximately 20 orbits of the Milky Way. 20 laps. That is all. 20 trips around a track so enormous that a single circuit outlasts the entire reign of the dinosaurs from first appearance to final extinction. Consider what one single orbit encompasses. When the Sun was last in approximately this same position in the galaxy, roughly 225 million years ago, the late Triassic was underway. The Great Permian Extinction, the worst mass extinction event in Earth's history, had wiped out roughly 90% of all marine species only 27 million years earlier. The first true dinosaurs were just appearing, small and insignificant, not yet risen to dominance. The Atlantic Ocean did not exist. The supercontinent Pangaea was still largely intact. One orbit ago, the Earth was a recognizably different world in almost every respect. 2 orbits ago, roughly 450 million years ago, life had only recently begun colonizing land. 3 orbits ago, the most complex organisms on the planet were simple multicellular creatures drifting through primordial seas. Everything that has happened in the history of complex life, every evolutionary branching point, every mass extinction, every recovery, every emergence of a new dominant form, all of it has taken place during the sun's slow crawl through a handful of galactic laps. The galaxy barely registers these events. It has been rotating for roughly 13 billion years. It will continue rotating for billions more. 1 orbit is a heartbeat. Our entire biological history is a flicker within that heartbeat. The entire recorded history of human civilization, every empire that has risen, every nation that has fallen, every scientific revolution, every work of art, every individual life ever lived and mourned and forgotten, all of it fits inside a fraction of a single galactic year. If you compressed the sun's full orbital period into 1 calendar year, all of recorded human history would occupy roughly the final 12 minutes of the last day. Not the last hour, not the last half day. 12 minutes. The time it takes to boil a kettle and drink the tea. That is how long your entire civilization has existed on the galactic clock. And this is the structure people believe they understand because they once saw it on a poster in a 7th grade classroom. Here is what that poster hides most effectively. It hides the emptiness. When you look at the neat spiral diagram with its labelled arms and its confident little arrow, your brain fills the image with implied density. You see the spiral arms as thick bands of light and matter, and you unconsciously imagine them as crowded places, as highways packed with stars, rivers of luminous material flowing around the galactic centre. But the Milky Way is overwhelmingly empty. Even in our region of the galaxy, neighbouring stars are separated by distances that take light itself years to cross. Each of those interstellar gaps represents trillions of miles of vacuum. In the denser inner regions near the galactic core, stars cluster more closely together, perhaps a light year or 2 apart in the most crowded zones. In the sparse outer reaches of the disk, and in the ancient halo above and below the galactic plane, individual stars drift through volumes of space so vacant that the nearest neighbour may lie dozens or even hundreds of light years away, separated by nothing but the faintest wisps of interstellar hydrogen and the invisible scaffolding of dark matter holding the entire structure together. The galaxy is not a crowded city. It is not even a sparsely populated countryside. It is closer to a desert that happens to contain an enormous number of isolated oases, each one separated from the next by a gulf so wide that crossing it at any speed humanity has ever achieved would require not centuries but tens of thousands of years. The poster cannot show you that emptiness. It cannot communicate the sheer vacancy that fills the space between the dots of light. The poster also hides time. The Milky Way is not a snapshot. It is not a frozen image captured at one moment and preserved. It is a process, an ongoing, evolving event that unfolds over timescales so vast they make geological time feel brisk by comparison. The spiral arms are not fixed features carved permanently into the structure of the galaxy like grooves in a record. They are density waves, regions where stars and interstellar gas temporarily bunch together, compress under their own gravity, trigger bursts of new star formation, and then disperse as individual stars drift onward in their orbits, like cars slowing down as they pass through a traffic jam that persists long after each individual car has moved on. The stars themselves pass through the arms over tens of millions of years, entering one side of a density wave and exiting the other. The arms persist as patterns. Their membership changes constantly. The galaxy you see tonight is not the galaxy that existed 100 million years ago, and it will not be the galaxy that exists 100 million years from now. It is a living, rotating, continuously evolving structure caught in a single frozen frame of a movie, so long that no observer in the history of the universe has ever watched more than a few frames of it play out. This brings us to the deepest problem with the familiar image, the problem that everything else in this story will build upon. The diagram gives you orientation. It tells you where things are relative to each other. Center here, sun there, arms curving outward in these directions. That orientation is useful. Astronomers need it. Students benefit from it. It is a necessary tool for organizing information about galactic structure. But orientation is not understanding. Knowing where you are on a map is not the same as knowing what the distances on that map actually mean in physical, tangible, felt terms. And the distances on the Milky Way map mean something so extreme, so far beyond the range of normal human experience, that merely labeling them with a number like 100,000 light-years does almost nothing to convey their reality. The number sits on the page like a street address printed on an envelope. It is seen and then quickly passed over. But this particular address points to a structure so vast that you could spend every second of every day of your entire life traveling through it at the fastest speed anything in the universe can move, and you would not cross even a fraction of it before you died. The familiar image of the Milky Way is not wrong, but it is dangerously incomplete. It gives you the shape without the scale, the layout without the loneliness, the map without the crushing weight of the actual distance. And because you have seen that image so many times, in so many contexts, repeated so casually and so often that it feels less like knowledge and more like wallpaper, you believe you know what the Milky Way is. You believe you have a working mental model of your home galaxy. You believe the next step is to zoom out and begin talking about bigger things. But you are not ready to zoom out, not yet, because the truth is, you have never actually confronted what 100,000 light-years means. You have heard the number. You have nodded at the number. You have never once felt the number enter your body, the way a real distance enters your body when you stand at the edge of a canyon and look across to the far rim and feel the empty air between you and it pressing against your chest. 100,000 light-years has remained, your entire life a symbol, an abstraction, a label on a poster, briefly noted, filed away, and never examined further. That abstraction is about to collapse, because we are now going to take that number off the poster and translate it into terms your brain can actually try to process. We are going to measure it in travel time, in communication delay, in the age of civilizations and the lifespan of entire species. We are going to ask what it would actually take to cross the Milky Way, or even to send a single whispered message from one side of it to the other, and the answer is going to make the galaxy feel like a very different place than the one you thought you knew. The comfortable image is about to break, and once it breaks, it does not go back together. Let us begin with something deceptively simple. A light year. You have heard this term your entire life. You have heard it used so casually, so frequently, that it probably feels like a unit you understand. It does not mean what your instincts tell you it means. A light year is not a measure of time. It is a measure of distance. Specifically, it is the distance that light travels through a vacuum in 1 year. Light moves at approximately 186,000 miles per second, not per hour, per second. In the span of a single sentence, light would travel far enough to circle the Earth more than 7 times. In 1 minute, it crosses roughly 11 million miles. In 1 hour, about 670 million miles. And in 1 full year, moving at that speed without interruption, light covers approximately 5.88 trillion miles. That is the length of a single light year, not billion, trillion. 5.88 followed by 12 zeros, written out in full, that number would stretch across the page in a line of digits long enough to make your eyes lose focus. And that is the distance that light, the fastest thing in the known universe, the absolute cosmic speed limit that nothing with mass can ever reach, covers in just 1 year of travel. The Milky Way is 100,000 of those. 100,000 light-years across. That means the full diameter of our galaxy, measured from one edge of the stellar disk to the other, spans roughly 588 quadrillion miles. If you wrote that number out, it would read 588 followed by 15 zeros. It is a number so large that no analogy can carry it faithfully into your understanding. It simply exceeds the range of the human nervous system entirely. You can hear it, you can carefully write it down, you can nod at it and agree that it is very, very large, but you cannot feel it because your brain was never built to feel distances of this magnitude. You evolved to judge the distance to a tree, the width of a river, the length of a day's walk across open terrain. 588 quadrillion miles is not a distance. It is an abstraction wearing the mask of a number. But let us try to crack that abstraction open. Let us start close and work our way outward, building the ladder rung by rung until the scale of the galaxy becomes undeniable, even to a brain that was never designed to process it. The nearest star to our Sun is Proxima Centauri, a small, dim red dwarf sitting approximately 4.24 light-years away. In cosmic terms, Proxima Centauri is practically next door. It is so close, by galactic standards, that it barely registers on any map of the Milky Way. If the galaxy were a continent, Proxima Centauri would be the house across the street. And yet even this nearest stellar neighbour exists at a distance so vast that reaching it with any technology humanity currently possesses would be functionally impossible within a single human lifetime. NASA's Voyager 1 spacecraft, launched in 1977, is currently the most distant human-made object in existence. It has been travelling through space for nearly 5 decades, moving at roughly 17 kilometers per second, or about 38,000 miles per hour. After all that time, Voyager 1 has covered a distance of approximately 163 astronomical units, where 1 astronomical unit is the distance between the Earth and the Sun. That is impressive by human standards. It is nothing by stellar standards. Voyager 1 has not yet travelled even 1 light-year from Earth. If it were aimed directly at Proxima Centauri, which it is not, it would need more than 73,000 years to arrive. 73,000 years. That is roughly 10 times longer than the entire span of recorded human civilization. Every dynasty, every republic, every technological revolution, every cultural epoch in human history could play out from start to finish, and then play out a second time, and then a third. And Voyager would still be drifting through interstellar space, not yet halfway to the nearest star. The Parker Solar Probe, the fastest spacecraft humanity has ever built, has achieved peak velocities approaching 700,000 kilometers per hour during its closest passes around the Sun. At that extraordinary speed, the probe could fly from New York to Tokyo in less than a minute. It could reach the Moon in roughly half an hour. And even at that speed, it would take the Parker Solar Probe approximately 6,300 years to reach Proxima Centauri. 6,300 years. That is longer than the entire history of ancient Egypt. You could start the journey when the first pyramids were being built and still not arrive by the present day. And Proxima Centauri is 4.24 light-years away. The Milky Way is 100,000. Do the arithmetic, and the result is numbing. If you could somehow sustain the Parker Solar Probe's peak velocity for the entire journey, crossing the full diameter of the Milky Way would take roughly 149 million years. If you used Voyager 1's speed instead, the trip would stretch to approximately 1.7 billion years. Billion, with a B. That is longer than the time that has elapsed since complex multicellular life first appeared on Earth. You could launch your spacecraft when the first animals were beginning to evolve in ancient oceans, and it would not reach the far side of the galaxy before the present day. The entire evolutionary history of animal life on this planet, from the Cambrian explosion to the emergence of human beings, would fit inside the travel time. Perhaps you think the answer lies in future technology. Perhaps some advanced propulsion system, nuclear pulse drives, antimatter engines, laser-propelled light sails could push a spacecraft to 10% of the speed of light. That is a speed no human vehicle has ever come remotely close to achieving, but physicists consider it at least theoretically possible within the laws of physics. At 10% of light speed, you could reach Proxima Centauri in roughly 44 years. That sounds almost manageable. A human lifetime, a career. But scale that same speed to the full diameter of the Milky Way, and you need 1 million years. 1 million years at 10% of the speed of light, just to cross your own galaxy. Homo sapiens as a species is roughly 300,000 years old. You would need more than 3 times the entire existence of modern humanity to make the trip. And 10% of light speed is an engineering fantasy that may never be realized. The galaxy does not care about your engineering timelines. It simply is what it is, and what it is too large. And that is assuming you could keep the spacecraft going. In reality, no human machine has ever been designed to operate for more than a few decades. The engineering challenges of building something that could function for millions or billions of years, maintaining its trajectory through the gravitational fields of countless stars, avoiding collisions with interstellar dust and debris, correcting its course without fuel, without maintenance, without any human intervention across timescales that dwarf the existence of our species. Those challenges are not difficult. They are currently impossible. The galaxy is not merely large. It is large on a scale that makes crossing it a physical absurdity with any propulsion system humanity has ever conceived. Now consider what this means for communication rather than travel. Forget spacecraft, forget physical journeys. Imagine instead that you simply want to send a message across the Milky Way, a radio signal, a pulse of light, a single electromagnetic whisper launched with all the energy a civilization can muster from one edge of the galaxy toward the other. Radio waves and light both travel at the same speed, the speed of light, 186,000 miles per second. This is the fastest that any information can travel through the universe. There is no cheat code, there is no shortcut. The speed of light is not a technological limitation that might be overcome with better engineering. It is a fundamental law of physics, woven into the structure of space-time itself. A signal sent from one edge of the Milky Way to the other, travelling at the speed of light, would take 100,000 years to arrive. 100,000 years. When that signal was sent, modern human civilizations did not exist. Anatomically modern humans were already present on Earth, but they lived as scattered bands of hunter-gatherers. Neanderthals still shared the planet with them. The last ice age had not begun. No human being had ever planted a crop, built a city, or written a single word. By the time the signal reached the far side of the galaxy, the civilization that sent it would almost certainly be unrecognizable, if it still existed at all. You cannot have a conversation across the Milky Way. You cannot even have a monologue. You can only shout into the void and hope that something on the other end is still listening 100 millennia later. There is a way to visualize this isolation that hits harder than any number. Humanity has been broadcasting radio signals into space for roughly 120 years, since the earliest experiments with radio transmission in the early 20th century. Those signals travel outward from Earth at the speed of light, expanding in every direction like a growing sphere. After more than a century of continuous broadcasting, that sphere, sometimes called humanity's radio bubble, has reached a diameter of approximately 240 light-years. That is the total extent of space that has even the faintest theoretical chance of detecting our existence. Every radio broadcast, every television signal, every radar pulse that has ever leaked from the surface of this planet is contained within that sphere. It represents the absolute outer limit of our electromagnetic footprint in the cosmos, and it is invisible on any map of the Milky Way. The bubble spans roughly 1/400th of the galactic diameter. In terms of volume, it occupies less than 1/millionth of the disk. If you drew the galaxy to scale and tried to mark the radio bubble, the dot would be too small to print. Humanity has been shouting into the Milky Way for over a century, and the shout has reached a volume of space so small it would not register as a single pixel on any image of the galaxy ever produced. At the current rate of expansion, our signals will need roughly another 24,000 years just to reach the nearest outer edge of the disk. The Milky Way is not ignoring us. It simply has not yet had time to notice we are here. Even communication across much smaller galactic distances faces this barrier. The galactic center, Sagittarius A star, sits roughly 26,000 light-years from Earth. The light you observe from that direction tonight, the infrared glow that penetrates the dust, the radio emissions that astronomers collect with their dishes, all of it left the galactic center approximately 26,000 years ago. When that light began its journey toward Earth, the last ice age was near its peak. Woolly mammoths roamed across northern continents. Human beings were living as nomadic hunter-gatherers, painting animals on cave walls, making tools from stone and bone. The light arriving from the galactic center tonight is a message from a time before agriculture, before cities, before writing, before anything you would recognize as civilization. And this is not light from some impossibly distant corner of the cosmos. This is light from the center of our own galaxy, the place around which everything else orbits, the heart of the structure we call home. Now turn that thought in the other direction. If an observer at the galactic center were watching Earth right now, they would not see human civilization. They would not see the pyramids, the Roman Empire, the Industrial Revolution. They would see Earth as it existed 26,000 years ago, a planet inhabited by small bands of Stone Age humans who had no concept that they lived inside a galaxy at all. Light from the Earth tonight will not reach the galactic center for another 26,000 years. Whatever happens on this planet between now and then, whatever triumphs or catastrophes define the next 26 millennia of human history, none of it will be visible from the center of the Milky Way until an amount of time has passed that is roughly 5 times longer than all of recorded history. This is what light years mean in practice. They are not just measurements of space, they are measurements of isolation. They encode a fundamental disconnection between different parts of the galaxy, a disconnection so deep and so permanent that no technology, no matter how advanced, can overcome it. The speed of light is not a wall you can break through. It is the speed at which information itself propagates through the universe. There is nothing faster. There is nothing that can carry a message, a signal, a particle of data from one place to another any quicker than light can do it. And light is too slow for the Milky Way. It is too slow by a factor that makes the galaxy feel less like a single unified place and more like a vast archipelago of isolated islands, each one separated from the others by seas that no ship can cross within any meaningful span of time. Consider what this means for the galaxy as a whole. The Milky Way cannot function as a connected system in any meaningful sense. Different regions of the galaxy do not know about each other. 12. Stars on one side of the disk have no causal relationship with stars on the other side. Events happening in the Perseus Arm right now, supernovae detonating, new planetary systems forming, entire civilizations potentially rising and falling, will not be detectable from our position in the Orion Arm for thousands of years, in some cases tens of thousands of years. The galaxy that you observe through a telescope tonight is not the galaxy as it currently exists. It is a mosaic of different moments in time, stitched together by the accidents of distance and the finite speed of light. Stars a few light years away appear roughly as they are now. Stars 1,000 light years away appear as they were a millennium ago. Stars near the galactic center appear as they were 26,000 years ago. Stars on the far side of the disk appear as they were before human beings existed in their modern form. You are not looking at one galaxy. You are looking at 100,000 different moments layered on top of each other, a time composite that your brain mistakenly interprets as a single coherent snapshot. No observer anywhere in the Milky Way has ever seen the galaxy as it actually exists at any single moment. It is physically impossible. The information needed to construct that picture would have to travel from every star in the galaxy to your position simultaneously. And because those stars sit at wildly different distances, their light arrives carrying news from wildly different eras. The galaxy is not a place. It is an accumulation of time disguised as space. And no amount of technology can fix this. Even a civilization that endured for millions of years, stationed observers across the disk and synchronized their clocks with impossible precision, would still be assembling a picture made of moments that do not coincide. The Milky Way exists as a totality only in theory, never in observation. And now let us confront the dimension that even astronomy enthusiasts often forget. The Milky Way's disk is roughly 100,000 light-years wide, yes, but it also has thickness. Outside the central bulge, the disk is approximately 1,000 to 2,000 light-years thick. People hear that number and think of it as small because it is being compared to the diameter. 1,000 light-years sounds thin when you place it next to 100,000. But strip away the comparison and consider that number in isolation. 1,000 light-years. That is the vertical dimension of the disk in our neighborhood of the galaxy. A signal traveling at the speed of light, straight up from the midplane of the disk to the top, would take roughly 500 to 1,000 years to complete the trip. A spacecraft traveling at Voyager 1 speed would need roughly 17 million years to cross the same distance. Even the narrow dimension of the Milky Way, the measurement that makes the galaxy look flat and thin in diagrams, represents a distance so vast that no human technology could cross it within the lifespan of any civilization we know of. The galaxy is not flat in the way a coin is flat, it is flat only in proportion. The proportions suggest thinness. The actual measurements, in absolute terms, suggest something immense in every direction, including the one that diagrams encourage you to dismiss as negligible. 1,000 light-years of thickness is not thin. It is only thin compared to 100,000 light-years of width, compared to anything human. It is bottomless. Let us also consider what lies between the stars, because the emptiness is not merely an absence, it is a defining feature. In our local neighborhood, the average gap between neighboring stars is roughly 4 to 5 light-years, but that average conceals tremendous variation. In some regions of the spiral arms, especially near active star-forming nebulae, stars cluster more closely. In the vast lanes between the arms, the density drops sharply, and you can travel for dozens of light-years through near-perfect vacuum without encountering a single stellar system. In the outer disk, beyond the Sun's orbital radius, the intervals between stars grow wider still, and in the halo, the dim outer reaches of the galaxy far above and below the main disk, individual stars can be separated by hundreds of light-years, each one drifting through a volume of space so empty it borders on philosophical. These interstellar voids are not like the emptiness of an unoccupied room. An empty room still contains air, roughly 25 quintillion molecules per cubic centimetre at sea level. Interstellar space, by contrast, contains on average about 1 atom per cubic centimetre. Some regions are even less dense than that. The space between stars is the closest thing to nothing that the universe contains, and that near nothing stretches for trillions upon trillions of miles in every direction, filling the gaps between the galaxy's hundreds of billions of stars with a vacuum so thorough that it makes the best laboratory vacuum on Earth look crowded by comparison. This means that when you look at the night sky and see stars scattered across it, you are experiencing an optical illusion produced by extreme distance. The stars appear close together because your eyes cannot perceive the depths separating them. Two stars that seem to sit side by side in a constellation may be hundreds of light-years apart along your line of sight, one far in front of the other, with an abyss of empty space between them. The constellations themselves are not real structures. They are patterns created by the accident of perspective, shapes drawn by connecting dots that have no physical relationship to one another. The galaxy does not look like the night sky. The night sky is a flat projection of a three-dimensional space, so deep and so empty that its true structure is invisible to the human eye. All of this means something that most people have never been forced to confront directly. The Milky Way is not a place you could explore. It is not a territory you could survey or map with spacecraft, or ever hope to become familiar with the way you become familiar with a city or a country or even an entire planet. Even if humanity survived for 1 million years and developed propulsion technologies far beyond anything currently imaginable, the overwhelming majority of the galaxy would remain permanently beyond reach. The distances are simply too large, the travel times too long, the energy requirements too extreme. We could potentially visit a handful of nearby stars within a few centuries if we develop the capability to travel at a significant fraction of the speed of light. A handful, perhaps a few dozen, perhaps, over millennia of sustained effort, a few hundred. But a few hundred stars is not the galaxy. It is a single neighborhood in a city of hundreds of billions. The rest, the overwhelming, crushing, suffocating majority of the Milky Way, would remain as inaccessible to us as it is right now, separated by gaps so wide that crossing them would take longer than most civilizations manage to persist before they collapse under the weight of their own history. This is the realization that never makes it into the textbook diagram. The poster shows you a galaxy and implies that you are part of it, that you live inside it, that it is yours in some meaningful sense. And technically, all of that is true. You are inside it. You are part of it. But inside does not mean connected to. You are inside the Milky Way the way a single termite is inside a cathedral. You are there. You exist within it. But the vast majority of the structure surrounding you is so far away, so unreachable, so separated from your position by distances that dwarf every journey ever taken by every member of your species combined, that your presence inside it confers almost no relationship to the whole. We live in one tiny corridor of the Milky Way, a slender thread of stars and gas within the Orion Arm, surrounded on all sides by distances that would take our fastest machines millions of years to cross. We cannot see most of it because dust blocks our view. We cannot reach most of it because the gaps between stars are measured in trillions of miles. We cannot communicate with most of it because our signals, even travelling at the speed of light, would take tens of thousands of years to arrive. The galaxy is our home in name only. In practice, we occupy a minuscule fraction of its volume and have no meaningful access to the rest. And here is what makes this even harder to accept. Everything just described applies only to the stellar disk, the main visible body of the Milky Way. The galaxy does not end where the stars thin out. Beyond the disk lies the dark matter halo, a vast invisible sphere of matter that does not emit light, does not absorb light, and interacts with ordinary matter only through gravity. Current estimates suggest this halo may extend out to roughly 1 million light-years in diameter, dwarfing the visible disk by an order of magnitude. When astronomers talk about the size of the Milky Way, they usually mean the stellar disk, the part you can observe. But the gravitational reach of the galaxy, the full sphere of space over which it exerts its influence, is vastly larger. If the visible disk is the campfire, the dark matter halo is the darkness of the entire forest surrounding it. We see the fire. We sit beside it. But the forest stretches in every direction far beyond the reach of its light. Even the distances we have discussed so far, the 100,000 light-years of the stellar disk, are only part of the story. The true gravitational domain of the Milky Way is so large that it nearly touches the halo of the Andromeda galaxy, 2.5 million light-years away. Two galaxies, each surrounded by a sphere of invisible mass so vast that the gap between them may already be closing, their halos interpenetrating in the dark matter realm long before their visible disks ever come close to colliding. But we are getting ahead of ourselves. The purpose of this part of the story was not to catalogue every component of the galaxy. It was to force one single fact into your awareness, a fact that the familiar diagram actively works to suppress. The Milky Way is not merely large, it is large in a way that makes the word large meaningless. It operates on a scale where the fastest thing in the universe, light itself, needs 100,000 years to cross it, where the most advanced spacecraft ever built by human hands would need more than 1 billion years to make the same journey, where a message shouted from one edge would not be heard on the other until an amount of time had passed that exceeds the entire span of recorded human history many times over. Those are not numbers designed to intimidate. They are not rhetorical exaggerations. They are measurements. They are the physical, verified, repeatedly confirmed dimensions of the structure you live inside. And they mean that the Milky Way is not a home the way your house is a home, or your city, or your country. It is a structure so large that most of it exists in a state of permanent separation from you, unreachable by any physical process, invisible behind walls of dust, and disconnected from your position by light travel times longer than all of recorded civilization. You have now heard what 100,000 light years means in terms of travel and communication. You know the number is too large for spacecraft. You know it is too large for radio signals to cross within any time frame that a civilization could survive to witness. You know that even the narrow thickness of the disk dwarfs any distance a human being has ever traveled or ever will. But there is something worse than knowing these distances. There is understanding what it feels like to actually live inside them. Because the Milky Way is not something you observe from the outside. You are embedded within it. You cannot step back and see the spiral. You cannot take the God's eye view that the poster gives you. You are trapped inside the structure, surrounded on every side by distances you cannot cross, looking outward through dust and gas at a galaxy that reveals itself only in fragments, only in ancient light, only in whispers that take millennia to arrive. What does it actually feel like to live inside a structure this large? What does the galaxy look like from the inside? And what does that interior view reveal about how lost we truly are? Step outside tonight, find the darkest sky available to you and look up. If conditions are right, you will see the Milky Way with your own eyes. It stretches across the sky as a pale, glowing river of light, wider in some places and narrower in others, brightest in the direction of the constellation Sagittarius, and faintest as it trails toward the opposite horizon. It looks serene. It looks close. If you did not know what you were looking at, you might mistake it for a cloud, a weather formation, something atmospheric and local. Generations of people across thousands of years looked at that band and saw exactly that. A splash of milk across the heavens, a road for spirits, a bridge between worlds. They had no idea they were looking at the interior of a galaxy from the inside. And that is the first thing you need to understand about living inside the Milky Way. You cannot see it. Not really. Not the way you see another galaxy through a telescope. Its full spiral structure laid out cleanly from edge to edge. Its arms and core and halo all visible in a single frame. You will never see the Milky Way that way, because you are embedded inside it. You are not an observer looking at the galaxy. You are a particle trapped within it, peering outward through layers of gas and dust and starlight, trying to reconstruct the shape of a structure you cannot step outside of. Everything you know about the Milky Way's spiral shape, its bar, its arms, their positions and extent, has been inferred, deduced, calculated from indirect measurements, pieced together from fragments of data the way an archaeologist reconstructs a shattered vase from a handful of recovered pieces. No human being has ever seen the Milky Way as a whole, and no human being ever will. That pale band of light across the sky is what happens when you look along the plane of the disk from inside it. You are seeing the combined glow of billions of stars too faint and too distant to resolve individually with the naked eye, all of them concentrated in the thin plane of the galactic disk, blurring together into a wash of diffuse light. The band is brightest towards Sagittarius because that is the direction of the galactic center, where stars pack together most densely. It is faintest in the opposite direction, toward the galactic anticenter, where you are looking outward through the thinner, sparser outer regions of the disk. The galaxy's structure is inferred from the clues it leaves in the sky, much like a person lost in fog interpreting the landscape by listening for sounds and sensing the slope of the ground beneath their feet. But even this foggy interior view is incomplete, because the fog is not uniform. It has holes and walls. Dense clouds of interstellar dust block visible light in huge swaths of the galactic plane, creating what astronomers call the zone of avoidance, a region that obscures roughly 10 to 20% of the entire sky as seen from Earth. In the direction of the galactic center, where the disk is thickest and the dust is most concentrated, more than 99% of visible light from objects beyond the central bulge is absorbed before it reaches us. Entire populations of stars, entire regions of the galaxy's structure, sit behind curtains of dust so thick that no optical telescope can see through them. For centuries, this obscuration led astronomers to wrong conclusions about our position in the galaxy. When William Herschel attempted to map the Milky Way in the 1780s, the dust made it appear as though the sun sat near the center, because the visible stars seemed to extend equally in all directions. It took more than a century of improved observations to realize that the apparent symmetry was an illusion created by our blindness. We were not at the center. We were simply unable to see far enough in certain directions to know where the center actually was. Modern astronomy has partially overcome this blindness by observing in wavelengths that dust cannot block. Infrared light passes through interstellar dust clouds the way headlights penetrate fog that would be opaque to the naked eye. Radio waves, particularly the 21-centimeter emission line of neutral hydrogen, travel through the entire galaxy essentially unimpeded, allowing astronomers to map the distribution of gas across the full disk. X-rays, gamma rays, and sub-millimeter radiation each reveal different components of galactic structure that visible light cannot reach. These tools have transformed our understanding. The central bar of the galaxy, its spiral arm structure, the distribution of star-forming regions, all of these were mapped primarily through non-optical observations, because optical astronomy alone is hopelessly limited by the dust. And yet the zone of avoidance is not merely an obstacle to seeing distant galaxies beyond the Milky Way. It is an obstacle to seeing our own galaxy. The same dust that hides extragalactic objects from view also hides enormous numbers of Milky Way stars, gas clouds, and structural features on the far side of the galactic disk. We cannot see the spiral arms on the opposite side of the galaxy in visible light. We cannot directly image the far half of the bar. We cannot photograph the star-forming regions on the far side of the galactic center any more than we can photograph the far side of a mountain while standing at its base. Our position inside the disk, combined with the dust that permeates it, means that we are structurally blind to roughly half of our own galaxy in optical wavelengths. The clean spiral diagram in the textbook shows two symmetrical halves of a galaxy. In practice, we have directly observed one half far better than the other. The other half is inferred, modelled, deduced from radio and infrared data, but never cleanly seen. But even with every wavelength at our disposal, we remain partially blind. Different instruments reveal different things. Infrared surveys show the distribution of older, cooler stars and heated dust. Radio surveys trace cold hydrogen gas and energetic particles. X-ray telescopes detect superheated plasma and the violent environments around compact objects. No single instrument sees the galaxy whole. Each one provides a different partial view, like examining a room through a keyhole that only shows you one color at a time. Red light through one keyhole, blue through another, heat signatures through a third. Astronomers spend entire careers assembling these partial views into composite maps, cross-referencing datasets, correcting for instrumental biases, and arguing about what the assembled picture actually means. The Milky Way we see in textbooks, that clean spiral diagram with its neatly labelled arms, is not a photograph, it is a reconstruction, an educated estimate, a best guess assembled from incomplete data, filtered through dust, distance, and the fundamental limitation that we can never leave our vantage point inside the structure we are trying to map. The Gaia spacecraft dramatically expanded the amount of data available for this reconstruction. Over its decade of operation, Gaia measured the positions, distances, and motions of nearly 2 billion stars with extraordinary precision, producing the most detailed three-dimensional map of the Milky Way's stellar population ever constructed. That map revealed structures no one had anticipated. The galactic disk is not flat. It is warped, bending upward on one side and downward on the other, like a record that has been left in the sun. The warp is not static. Gaia's motion data showed that the disk oscillates, wobbling over time, possibly driven by gravitational interactions with satellite galaxies like the Sagittarius dwarf, which has been falling into the Milky Way and disturbing its structure for billions of years. The spiral arms turned out to be more numerous and less sharply defined than older models suggested. The bar at the galaxy's center was confirmed to be longer and more prominent than earlier observations had indicated. Stellar streams, the remnants of smaller galaxies torn apart by the Milky Way's gravity, threaded through the halo in patterns that recorded a history of galactic cannibalism stretching back more than 10 billion years. Gaia showed that the galaxy is not the static, orderly structure the diagram implies. It is a dynamic, messy, scarred thing, still digesting galaxies it consumed billions of years ago, still vibrating from collisions that happened when the Earth did not yet exist. And Gaia's nearly 2 billion stars, as extraordinary as that catalogue is, represent at most a few percent of the galaxy's total stellar population. The remaining hundreds of billions of stars are too faint, too distant, too obscured by dust, or too lost in the crowded glow of the inner galaxy to have been individually measured. We have catalogued a fraction. The rest remains uncounted, uncharted, invisible. This brings us to the part of the galaxy that lies in the direction we can see least. The galactic center, 26,000 light-years away, is the most extreme environment in the entire Milky Way, and we will never visit it. Not because it is far, although it is unimaginably far by any human standard, but because what exists there is hostile to everything we understand about habitable space. The innermost few hundred light-years of the galaxy contain the central molecular zone, a vast ring of dense gas and dust where temperatures, radiation levels, magnetic field strengths, and turbulence all reach values that have no counterpart anywhere else in the Milky Way. The gas here is denser by orders of magnitude than the interstellar medium near the Sun. Magnetic fields are hundreds of times stronger than in our local neighborhood. The radiation field, the combined electromagnetic output of the densely packed stellar population, is so intense that conditions in the central molecular zone resemble those found in starburst galaxies billions of light-years away. Environments so extreme that astrophysicists study them as analogues for conditions in the early universe. Massive young star clusters burn through their fuel at ferocious rates, flooding the surrounding space with ultraviolet radiation powerful enough to ionize gas across dozens of light-years. Supernova remnants overlap, their shock waves crashing into each other in a chaotic tangle of superheated plasma. And at the very center of it all sits Sagittarius A star, the 4 million solar mass black hole, surrounded by a swarm of stars orbiting at thousands of kilometers per second, some of them completing full orbits in as little as a dozen years, whipping around the black hole at velocities that would tear apart any object not held together by its own internal forces. If you could somehow stand on a planet near the galactic center, the sky above you would be unrecognizable. The stellar density in the innermost region of the Milky Way is roughly 10 million stars per cubic parsec, compared to about 1/5 of a star per cubic parsec in the Sun's neighborhood. That is a concentration approximately 50 million times greater than what we experience. Astronomers have calculated that if the Sun were relocated to within a parsec of the galactic center, the night sky would contain approximately 1 million stars each brighter than Sirius, the most luminous star currently visible from Earth. The combined starlight pouring in from all directions would be roughly 200 times brighter than the full moon. Midnight would be bright enough for everyday tasks under starlight. True darkness would not exist. There would be no real night, only varying degrees of brilliance as different stellar populations wheeled across an endlessly luminous sky, and it would not be safe brilliance. The ultraviolet and X-ray radiation saturating that region would be intense enough to strip atmospheres, sterilize planetary surfaces, and shatter the molecular chemistry that biological life depends on. Around Sagittarius A star itself, stars crowd within 100 astronomical units of each other, comparable to the width of our solar system. In our neighborhood, the nearest star sits more than 268,000 astronomical units away. Near the galactic center, stellar neighbors are roughly 2,600 times closer. The difference between our sky and that sky is not a matter of degree. It is a difference in kind, as absolute as the difference between a quiet clearing and the interior of a blast furnace. This region is as foreign to us as any place in the universe. It is part of our galaxy, technically part of our home, but it might as well exist in another cosmos. The environment near the galactic center would be lethal to any life form that depends on the kind of stable, low radiation conditions found in the sun's neighborhood. The density of stars is so high that the night sky from a planet near the galactic center would blaze with light from every direction. A sky so saturated with starlight that familiar constellations would dissolve into a solid wash of luminance. There would be no real darkness. The concept of night as we know it would not exist. And the gravitational chaos of so many stars packed so closely together would destabilize planetary orbits over timescales far shorter than those needed for biological evolution to produce complex life. We will never go there, not because we lack the will, but because the physics of distance prevents it. 26,000 light-years is the distance. You already know what that means in travel time. But even setting aside the distance, the galactic center is not a destination. It is a furnace. It is the most extreme astrophysical laboratory accessible to human observation, and the only reason we can study it at all is that infrared and radio waves carry its secrets through the intervening dust to our instruments. We observe the galactic center the way deep-sea creatures might observe the surface of the ocean, from below, through a vast column of water that distorts and attenuates the light, receiving only faint filtered signals from a world that operates under entirely different rules. Now turn your attention in the other direction, away from the galactic center, toward the stars that surround us in our immediate neighborhood. This is the only part of the galaxy that we have anything resembling real knowledge of. The solar neighborhood, the volume of space within roughly 200 light-years of the Sun, has been mapped in extraordinary detail by Gaia and by ground-based surveys. Within this small bubble, we know the positions, motions, temperatures, compositions, and evolutionary stages of millions of individual stars. We can identify binary systems, measure stellar rotation rates, detect exoplanets through the wobble they induce in their host stars, and trace the chemical history of stellar populations across billions of years. Within this neighborhood, astronomy is precise, detailed, and rich. But this neighborhood is tiny. A sphere of space 200 light-years in radius sounds large in absolute terms, and it is. But compared to the full extent of the Milky Way, it is vanishingly small. A bubble 400 light-years across occupies roughly 1/250th of the diameter of the galaxy. In terms of volume, it represents an almost immeasurably small fraction of the full galactic disk. The number of stars within this well-mapped bubble is perhaps a few million. The galaxy contains hundreds of billions. We have detailed knowledge of our own street corner. The rest of the city stretches away from us in every direction, known to us only through dim impressions and statistical estimates, its individual buildings and rooms and inhabitants reduced to smudges of unresolved light. The contrast between what we know locally and what we know about the wider galaxy is stark enough to be unsettling. Within a few dozen light-years of the Sun, astronomers can tell you the temperature of a star to within a few degrees, its chemical composition down to trace elements, its age within a few 100 million years, whether it has planets and how many, and whether those planets orbit within the zone where liquid water could exist. That is intimate knowledge. That is the kind of detail that makes a region feel known and real. Now consider a star 10,000 light-years away, deep in the Sagittarius arm. Astronomers can tell you that it exists. They might be able to estimate its approximate spectral type and luminosity class. They might, with great effort and favourable conditions, be able to measure its radial velocity and rough distance, but they cannot tell you whether it has planets. They cannot tell you its age with any precision. They cannot resolve any structure around it, cannot detect any companion stars below a certain brightness, cannot say anything meaningful about the space surrounding it. The star is a point of light in a catalogue, labelled with a string of numbers, known only as a statistical member of a population. There are hundreds of billions of such entries in the Milky Way. Each one is a world unto itself, a site of potential complexity and strangeness, and we know almost nothing about any of them individually. Beyond this local bubble, our knowledge degrades rapidly. Stars become harder to observe individually as distance increases. Dust interferes. Crowding confuses instruments that cannot separate overlapping stellar images. Distances become less certain because the geometric parallax method, the gold standard of astronomical distance measurement, loses precision beyond a few thousand light years. Beyond roughly 10,000 light years, individual stars in the disk become increasingly difficult to study in any detail. They blur into the statistical background of the galaxy, countable in aggregate but unknowable as individuals. Each of those distant, blurred points of light is a star, possibly with its own planetary system, possibly harboring conditions unlike anything we have encountered, and we know almost nothing about any of them specifically. They are data points, not places, numbers in a survey, not worlds we could describe. The galaxy is full of stars about which we can say almost nothing, except that they exist and that they are very far away. This is the reality of living inside the Milky Way. Not the clean, omniscient view from the textbook, where every arm is labelled and every feature is named, but the actual lived experience of being embedded in a structure so large that most of it is beyond observation, beyond reach, and beyond any meaningful form of contact. We inhabit a small, well-lit room in an enormous dark building, and the hallways stretching away from us in every direction disappear into shadows we cannot penetrate. We know the building is vast because we can hear echoes from distant rooms, faint signals arriving through walls and corridors, filtered and delayed and distorted by the medium they travelled through. But we have never walked those hallways. We have never opened those doors. We have never seen what occupies the rooms at the far end of the building, and we never will. Between the spiral arms, the galaxy contains vast inter-arm regions where the density of stars drops sharply, creating corridors of relative emptiness that stretch for thousands of light years. These are not true voids. Stars exist within them, but the concentration is so much lower than within the arms that they represent genuine structural gaps in the galaxy's interior, enormous gulfs of sparse space that a traveller would have to cross to move from one arm to the next. The Sun itself sits between the inner edge of the Orion arm and the neighbouring Carina Sagittarius arm, and the gap between them spans thousands of light years. Within the arms, dense molecular clouds give birth to new stars in spectacular bursts of activity, their interiors collapsing under gravity to ignite nuclear fusion in fresh stellar cores. Between the arms, that process slows to a crawl. The gas is thinner, the gravitational triggers are weaker, the landscape is quieter, emptier, more desolate. If the spiral arms are the rivers of the galaxy, the inter-arm spaces are the dry plains between them, vast and silent and crossed only by the slowest and most patient of travellers. The galaxy also extends vertically in ways that the flat disk diagram completely obscures. Above and below the plane of the disk, a sparse halo of ancient stars extends outward for tens of thousands of light years. These halo stars are among the oldest objects in the Milky Way, some of them nearly as old as the universe itself, formed during the galaxy's earliest epochs before the disk had fully settled into its current flattened shape. Many of them do not orbit in the same plane as the disk at all. They follow eccentric, highly inclined paths that take them far above and below the galactic midplane, passing through the disk like needles through fabric before arcing back out into the sparse reaches of the halo. Their orbits are relics of the chaotic conditions under which the galaxy originally assembled, before gravitational interactions had time to flatten the majority of the stellar population into the organized disk we see today. Globular clusters populate this halo as well, dense spherical collections of hundreds of thousands of stars bound together by their mutual gravity, orbiting on elongated paths that take them far above and below the galactic plane, before swinging them back through the disk. These clusters are living fossils, their stars preserving the chemical signatures of the early universe, poor in the heavy elements that had not yet been forged in sufficient quantities by generations of stellar nucleosynthesis. Some of the globular clusters orbiting the Milky Way contain stars that formed within the first billion years after the Big Bang, making them older than almost anything else we can observe in the galaxy. They carry information about a version of the Milky Way that no longer exists, a younger, smaller, more chaotic proto-galaxy that had not yet consumed the dozens of smaller galaxies whose remains now litter the halo as streams and debris. The halo is a graveyard and a museum simultaneously, populated by the oldest surviving stars in the galaxy and by the scattered remnants of dwarf galaxies the Milky Way devoured long ago. It is enormous in spatial extent, reaching distances where the galaxy's boundary with intergalactic space becomes ambiguous and undefined, and almost no one thinks about it when they hear the name Milky Way, because it does not appear in the clean disk diagram. It is the part of the galaxy that the familiar image forgets, the invisible architecture that surrounds the visible structure on every side. All of these features, the dust-blocked views, the zone of avoidance, the alien galactic center, the tiny, well-mapped local bubble, the dark interarm corridors, the ancient halo, combine to create a picture of the Milky Way that is radically different from the one most people carry in their heads. The galaxy is not a known place. It is not a mapped territory. It is not a neighborhood we understand. It is a structure so vast, so complex, so opaque from the inside, and so far beyond our ability to traverse or even observe in its entirety, that calling it home requires stretching that word past the point where it retains any of its ordinary meaning. You call your house a home because you can walk through every room, you can open every door, you can stand at one end and see the other. You know what is inside it, you control the space. The Milky Way is nothing like that. You occupy a tiny bubble inside it. You can see a fraction of its contents. You can reach none of it beyond your immediate stellar neighborhood. You cannot communicate with most of it within any time frame that has meaning for a human civilization. You cannot observe most of it directly because dust and distance and the limitations of your instruments conspire to keep the overwhelming majority of the galaxy hidden from you. You live inside the Milky Way the way a single cell lives inside a body, performing its function in its local environment, utterly unaware of the organs and systems and vast architecture that surround it on every side. And yet this is the structure we treat as settled knowledge, the familiar place, the starting point, the galaxy that needs no further examination before we zoom out to contemplate the wider universe. The truth is that we do not understand it. We have barely begun to map it. We have observed a small percentage of its stars individually. We have visited none of them. We have reached none of its other arms, none of its halo, none of its center, none of its far side. The Milky Way contains entire regions that are more mysterious to us than the surfaces of the nearest planets. Regions where conditions are so extreme or so distant that our best instruments return only blurred impressions and educated guesses. We are not citizens of the Milky Way. We are prisoners of a small corner of it, confined by distance and dust, and the speed of light to a slender thread of local space, surrounded on every side by a galaxy so immense that most of it might as well not exist for all the contact we will ever have with it. We orbit within it. We are made of its material. Our atoms were forged in its stars, scattered by its supernovae, swept into the collapsing cloud that became our solar system 4.5 billion years ago. In that sense, we belong to the Milky Way completely. We are its product, its offspring, its consequence. But belonging to something is not the same as knowing it. A drop of water belongs to the ocean. It does not comprehend the ocean. It has never experienced the ocean's full extent. It will never know what lies on the far side of the currents it drifts through. It simply exists in its local volume, moved by forces it cannot perceive, surrounded by a vastness it cannot measure. That is us. That is our relationship to the Milky Way. We belong to it utterly, and we know almost nothing about it. And the most unsettling part of that realization is still ahead, because everything we have discussed so far, the distances, the travel times, the blindness, the isolation, has been factual, mechanical, a matter of physics and measurement. What remains is the question that the physics points toward but cannot answer on its own. What does it mean that the place you call home is already too large to know? What does it do to the idea of home itself when the structure bearing that name stretches so far beyond your reach that reaching is pointless? What happens to the sense of belonging when the thing you belong to is so vast that your presence inside it carries no weight, confers no familiarity, creates no intimacy? That is the question we have been building toward, and the answer is not comfortable. Go back to the beginning, go back to the image, the spiral, the arms, the tiny arrow. You are here. You have seen it so many times that it probably feels like memory rather than learning, something you absorbed rather than studied. A fact about the world as basic and unexamined as the colour of the sky. The Milky Way is our galaxy. It is shaped like a spiral. We live somewhere in it. Simple, settled, done. But it is not done. You know that now. You have spent this entire journey watching that simple image come apart under the pressure of real numbers, real distances, real physics. You have seen that the galaxy is 100,000 light-years across, and that this distance defeats every mode of travel and communication that humanity has ever invented or can plausibly invent. You have seen that most of the galaxy is invisible to us from the inside, blocked by dust, smeared by distance, fragmented into partial views that no single instrument can assemble into a whole. You have seen that even the best star catalogue ever compiled covers only a few % of the Milky Way's total stellar population. You have seen that the galactic centre is an environment so extreme it would be lethal to any form of life we understand. You have seen that our local neighbourhood, the only part of the galaxy we know in any real detail, is a vanishingly small fraction of the whole. All of that is physics, measurement, data. It is the factual architecture of a problem that has been building from the beginning. But the problem itself is not factual, it is emotional. And the emotion is this: the Milky Way is supposed to be home, and home is not supposed to feel like this. Think about what the word home means to you. Not its dictionary definition, its felt meaning, the sensation it produces in your body when you hear it or say it. Home is the place you know, the place where the walls are familiar, where the distances are walkable, where you can move from one room to another and understand the space you are moving through. Home implies intimacy. It implies boundaries. It implies a scale that your body and your mind can encompass without strain. A house is a home. A neighbourhood can be a home. A city, with effort and time, can become a home. A country stretches the word, but people use it. The earth itself in certain poetic moods is called home, and the word still holds barely, because the earth is at least a place you can see the edges of from space. A bounded sphere whose full extent has been photographed and mapped and explored by machines, if not by every individual human being. The Milky Way is none of these things. It has no edges you can see. It has no boundaries you can reach. It has no rooms you can walk between. It cannot be photographed from the outside because no human instrument has ever been outside it and none ever will be within any foreseeable future. Its distances are not walkable. They are not drivable. They are not flyable. They are not crossable by any means at any speed within any time frame that a human civilization could survive to complete. The Milky Way is a structure so vast that the light crossing it, the fastest possible signal in the universe, takes longer to make the trip than human civilization has existed. And yet we call it home. We use that word casually, comfortably, the way we might refer to a hometown or a street address. Our home galaxy. It rolls off the tongue. It fits neatly into a sentence. It sounds warm. But the warmth is a trick of language, not a feature of the underlying reality. We call the Milky Way home because we have a name for it and because we live inside it, and those two facts together create a psychological impression of familiarity that has nothing whatsoever to do with actual knowledge or actual closeness. You are familiar with the Milky Way, the way you are familiar with the country you were born in, even if you have only ever seen a fraction of it. The name gives you a sense of ownership. The fact of living inside it gives you a sense of belonging. But ownership without knowledge is hollow, and belonging without access is an illusion. You belong to the Milky Way in the same sense that a single grain of sand belongs to the Sahara. The grain is there. It is undeniably part of the desert. But the desert stretches for thousands of miles in every direction, and the grain has no relationship with any of it beyond the few neighbouring grains it happens to touch. This is the quiet devastation hiding inside the title of this story. The true size of the Milky Way is hard to accept, not hard to calculate, not hard to verify, hard to accept. Because accepting it means accepting that the place you call home is so large, it does not function as a home in any meaningful sense. It does not shelter you. It does not contain you in the way a home contains you. It does not make the space around you feel known or navigable or safe. It simply exists at a scale so far beyond the reach of your body and your mind, and your instruments and your species, that you might as well be living inside infinity for all the practical difference it makes. And this is where human biology becomes part of the story, because the difficulty is not just conceptual, it is neurological. Your brain was not designed for this. It was designed for a world measured in footsteps and horizons, not in light years and galactic orbits. The human visual system can perceive depth accurately out to about 100 or 200 feet. Beyond that, your ability to judge distance degrades sharply. You rely on contextual cues, the size of familiar objects, the haziness of distant mountains, the curvature of roads, to estimate how far away things are. Remove those cues and your depth perception collapses. Ask you to estimate the distance to a star, and your brain has literally nothing to work with. It was not built for that task. It did not evolve under any pressure to perform that task. No ancestor of yours ever needed to judge the distance to an object 4 light years away in order to survive and reproduce. The hardware simply does not exist. Your intuition for distance has an effective range. You can feel the length of a walk across a parking lot. You can feel the drive from one city to another. You can feel, with some effort, the span of a cross-country trip, the hours of driving, the changing landscape, the fatigue that accumulates over hundreds of miles. But somewhere around that scale, a few hundred miles, your intuition reaches its limit. Beyond that, distances become numbers rather than sensations. You hear them, you process them intellectually, but they do not land in your body the way a walk distance lands in your legs, the way a long drive lands in your back and your eyes. The distance between New York and London is a number you know. It is not a distance you feel unless you have personally flown it, and even then, the experience is compressed into a sealed cabin where the actual distance passing beneath you is invisible and abstract. Beyond a few hundred miles, you are translating numbers, not feeling space. This is why the number 100,000 light years slides off your mind like water off glass. Your brain registers that it is large. It files it in the same category as other large numbers: government budgets, national populations, the age of the Earth, numbers that are acknowledged as big but never truly internalized. You can say the number. You can write it down. You can compare it to other numbers and confirm that it is very large indeed. But you cannot feel it the way you feel the distance across a room, or the length of a city block, or the drive from one town to another. Those distances live in your muscles and your nervous system. They were calibrated by experience. 100,000 light years lives nowhere in your body. It is a fact you carry in language, not in sensation. And that is why the Milky Way can be your home for your entire life without ever feeling vast. The vastness is real, but your brain is not equipped to register it. The diagram on the poster exploits this limitation. It gives you a shape, and your brain, starved of real spatial data, accepts the shape as the reality. The poster becomes the Milky Way in your mind, 6 inches across, fits on a wall, manageable. The real Milky Way does not fit on a wall. It does not fit in a mind. It does not fit in a species. It is operating on a scale that was never meant for you, a scale that predates you by billions of years and will outlast you by billions more, a scale on which your entire civilization is a chemical accident happening on a rock in one corner of one arm, of a structure so large that the accident will never be noticed from any other part of it. Now consider something that might make this worse. The Andromeda Galaxy, the nearest large galaxy to the Milky Way, sits approximately 2.5 million light-years away. That sounds like an incomprehensibly greater distance than the diameter of our galaxy, and it is. But do the ratio and something uncomfortable emerges. 2.5 million divided by 100,000 is 25. The distance to the nearest major galaxy is only about 25 times the diameter of our own. That is not a gulf between fundamentally different scales. That is a modest multiplier. In everyday terms, if the Milky Way were a city 1 mile wide, Andromeda would be 25 miles away. Close enough to drive to in half an hour, close enough to see on a clear day. The gap between galaxies, which we tend to think of as a chasm between cosmic categories, is actually surprisingly narrow when measured in units of galactic diameter. The Milky Way is already so large that the space between it and the next galaxy over is not some vast qualitative leap into a different regime of distance. It is merely a continuation of the same crushing scale that the galaxy itself already operates on. This means something profound about the Milky Way's size relative to the cosmos. The galaxy is not a small object embedded in a much larger universe the way a marble sits inside a gymnasium. It is an enormous object embedded in a universe that is larger still, but not as dramatically larger as most people assume. The Milky Way already contains within its diameter a significant fraction of the distance to the next major landmark in the cosmic landscape. It is not a stepping stone to bigger things. It is not a prelude to the real immensity. It is already the immensity. It is already operating at a scale where crossing it would take longer than human civilizations tend to last. And the jump to the next galaxy over is not a leap into a fundamentally different category of distance. It is merely a continuation, a modest multiplier applied to a baseline that was already incomprehensible. The Milky Way does not prepare you for the universe. It overwhelms you before the universe even enters the conversation. This is what people miss when they rush past the Milky Way to talk about bigger things. They treat our galaxy as the familiar part, the known quantity, the solved problem. They say, our galaxy contains 400 billion stars, in the same tone they might use to say, France is in Europe, as though stating the fact were the same as understanding it. Then they zoom out to galaxy clusters, to superclusters, to the cosmic web, to the observable universe, to the theoretical multiverse, stacking larger and larger numbers on top of each other in a race to reach the biggest possible scale. And the audience nods along, overwhelmed but compliant, carried forward by momentum and spectacle, because each new number is presented as a step on a ladder, and ladders are supposed to be climbed one rung at a time. The assumption is that you process the previous rung before stepping onto the next one. The assumption is that the Milky Way rung held your weight. It did not. It could not. The first rung is already broken. The first rung, the Milky Way itself, is already too large to stand on with any confidence. If you have not absorbed what 100,000 light-years means, truly absorbed it, felt it push against the walls of your comprehension and fail to fit, then 2.5 million means nothing. 10 billion means nothing. 93 billion means nothing. You are just adding abstractions to abstractions, piling symbols on top of symbols, and the pile grows taller but never heavier, because none of the numbers have any weight in your body. The Milky Way is where the weight has to land first. It is the first real confrontation with cosmic scale, the first place where the numbers stop being trivia and start being something that could, if you let them in fully, rearrange the way you think about your position in existence. Return to the galactic year, 225 million years per orbit. You have heard this number before, earlier, and you filed it away as a measure of the galaxy's size. But now, consider it not as a measurement, but as an experience. What does it mean to live inside a clock that ticks this slowly? It means that the galaxy does not notice you. It does not notice your species. It does not notice the rise and fall of your civilizations, the birth and death of your religions, the invention and obsolescence of your technologies. All of human history, from the first campfire to this moment, occupies less than 1/200th of a single galactic orbit. The Sun has completed 20 orbits in its entire lifetime. Dinosaurs dominated the Earth for roughly 3/4 of a single orbit. The evolution of mammals from tiny nocturnal creatures to the vast diversity of modern species took roughly 1 orbit. Every ice age, every warm period, every mass extinction, every recovery, every branching point in the tree of life that led eventually to you, all of it fits inside the lazy tick of a galactic clock that will keep ticking for billions of years after your species has vanished. The galaxy does not operate on your timescale. It does not acknowledge your timescale. It is not even aware that your timescale exists. You are a process happening too fast and too small to register on the instruments of galactic time. The stars around you will still be orbiting the galactic center long after the Sun has exhausted its fuel and expanded into a red giant and shed its outer layers and collapsed into a white dwarf and cooled into darkness over trillions of years. The galaxy will still be rotating, still processing, still evolving, long after every trace of Earth and everything that ever lived on it has been recycled into interstellar gas and incorporated into new stars that will themselves be born, burn, and die without any knowledge that you were ever here. And this is the galaxy you call home. This is not a comfortable realization. It is not supposed to be. This entire journey has been a process of discomfort, a slow, methodical dismantling of the psychological safety that the word home is supposed to provide. The diagram gave you comfort. The numbers took it away. The distances made the comfort impossible to rebuild. The interior blindness showed you that even the comfort of knowledge is denied to you. And now, at the end, you are left with a structure that bears the name home, but possesses none of the qualities that the name implies. Home is supposed to be bounded. The Milky Way has no definite edge. Its stellar disk fades gradually into a halo, that fades gradually into the dark matter envelope, that fades gradually into the intergalactic medium. There is no line you can draw and say this is where the Milky Way ends. It dissolves. It bleeds into its surroundings. It is not a container. It is a gradient. Home is supposed to be knowable. The Milky Way is mostly unknown. We have measured a fraction of its stars. We cannot see through its dust. We cannot observe the far side of its disk in optical light. We cannot visit or communicate with the overwhelming majority of its volume. We know its approximate shape, its approximate size, its approximate contents, but approximation is not knowledge. It is a sketch drawn from a single vantage point by an observer who cannot move. Home is supposed to be reachable. Every part of a home should be accessible to the people who live in it. You should be able to walk to the kitchen, open the front door, step into the garden. The Milky Way contains regions that are permanently unreachable by any physical means. Not temporarily unreachable, not unreachable with current technology, but unreachable by any technology consistent with the known laws of physics and the finite speed of light. Most of the galaxy is causally disconnected from us on any timescale shorter than tens of thousands of years. We cannot get there. We cannot send anything there. We cannot receive anything from there within the lifespan of any project any human institution could sustain. Home is supposed to be intimate. The Milky Way is the opposite of intimate. It is cold, it is vast, it is mostly vacuum. It is filled with distances so large they cannot be crossed, and timescales so long they cannot be witnessed. The spaces between its stars are not merely empty. They are actively, aggressively, structurally empty. Trillions of miles of nothing separating each island of matter from the next. A vacuum so thorough that a single atom per cubic centimetre counts as crowded. The galaxy is not a neighbourhood where you might bump into a fellow inhabitant on a walk. It is a void with occasional interruptions, a silence broken only by rare pinpricks of fusion light scattered across distances that would take your fastest machines millions of years to bridge. There is no warmth in this structure. There is no shelter. There is only space, unimaginable quantities of it, stretching in every direction from your position with a patience and an indifference that has nothing to do with you and never will. And yet we are here. We exist inside this structure. We are made of its material. We orbit its center. We see its light every night, that pale band across the sky, and we call it ours. There is something defiant in that, something stubbornly human about claiming a galaxy as home, even when the galaxy offers no warmth, no shelter, no recognition of your presence. You are a temporary arrangement of atoms that the galaxy assembled by accident and will disassemble without pausing to notice, and still you look up at it on a clear night and say, "That is where I live." Maybe that is enough. Maybe home does not need to be knowable or reachable or intimate. Maybe it only needs to be the place where you are, the place that made you, the place whose materials you borrow for the duration of your existence before returning them to the cycle. The Milky Way gave you every atom in your body. The calcium in your bones was forged in a star that died before the sun was born, a star whose name no one knows, a star that burned through its fuel and collapsed, and exploded in a supernova that scattered heavy elements across a region of space that would eventually, billions of years later, collapse again into the cloud that became our solar system. The iron in your blood was created in another such explosion, or perhaps the same one, a detonation so violent it blazed with the light of several billion suns, pouring freshly synthesized elements into the interstellar medium like a dying gift to future worlds. The oxygen you are breathing right now was synthesized in the nuclear furnace of a massive star that no longer exists anywhere in the universe, a star whose light has long since faded from the sky, whose collapsed core may now be a neutron star or a black hole drifting unseen through the disk. You are not just inside the Milky Way, you are made of the Milky Way. You are the galaxy, temporarily organized into a pattern complex enough to look up at itself and wonder what it is. But that does not make the scale easier to hold. It makes it stranger, because now you are not just a small thing inside a large thing. You are a small piece of the large thing, a fragment of the galaxy that has somehow become aware of the galaxy's size and is struggling to accept what it has learned. The Milky Way is examining itself through you, and what it finds is that it is too large to comprehend, too vast to cross, too old to witness, and too indifferent to care. The galaxy does not know you are here. It has never known. It does not know that it is a galaxy. It is simply matter and energy and gravity, doing what matter and energy and gravity do, on timescales that make your existence vanish into statistical noise. The true size of the Milky Way is hard to accept, because it is not an answer to a question. It is the collapse of an assumption. The assumption that home means something at galactic scale. The assumption that because we have a name for the galaxy, and a diagram of its shape and an arrow pointing to our location, we have some meaningful relationship with the structure we inhabit. We do not. We have a location. We have an address. But the building at that address is so large that the word building no longer applies. It is something else, something that our language was not designed to describe and our minds were not designed to contain. 100,000 light years across, between 200 and 400 billion stars, a single orbit taking 225 million years, most of it invisible from the inside, most of it unreachable by any technology that obeys the laws of physics, most of it unknown to the species that claims it as home, and all of it named home by a civilization that has existed for less than 1/40,000th of a single galactic rotation, a civilization that cannot see most of the structure it inhabits, cannot cross any significant fraction of it, and cannot even agree on how many stars it contains. Before you ever think about the size of the universe, before you ever try to wrap your mind around 2 trillion galaxies or 93 billion light years of observable space, or the theoretical possibility that reality extends infinitely beyond your cosmic horizon, sit with this first. Sit with the Milky Way. Sit with the fact that even here, even in the galaxy you were born inside of, the galaxy whose name you have heard since childhood, the galaxy that is supposed to be the starting point, the familiar ground, the first rung of the cosmic ladder, even here, the scale has already defeated you. The distances are already too large. The timescales are already too long. The emptiness is already too deep. The word home has already been stretched past the point where it means what you need it to mean. The Milky Way is not too large compared to something else. It is too large compared to you. It is too large compared to your species, your history, your instruments, your imagination. It is already, before you take a single step beyond its dissolving borders, more than you can hold in your mind or your lifetime, or your civilization's entire span of existence. And the hardest thing to accept about the true size of the Milky Way is not any particular number, not any single distance or travel time or light-year count. It is the quiet, persistent, irreversible realization that you live inside something that was never yours to comprehend, and that the place you call home was always, from the very beginning, too vast to be a home at all.